All right. So welcome here to this webinar on the physics class. We are going to do kind of a review of the physics class, take a look at what the class is going to be about, answer also questions for you, not only about this class, but about anything related to the academy and how things are going to go. And also, I would like to give a little, if you wish, mini lesson in physics. Okay, all right. So I hope that is all interesting for you. And again, if you have questions, just feel free to ask them. All right. To begin with, I'm going to share my screen with you. Okay. And I'm going to actually start by doing a little kind of overview of the website. Several people have asked, and said, "Oh, I kind of get lost in the website and how things work and so on." So I'm going to do a little overview of the website and how things are organized here. Okay. So first of all, you log in into the website by clicking, you log out by clicking on your profile icon, and then you have this power icon here on this corner. All right. And so you click in there and it takes you back to the landing page. All right. So the landing page is basically the home page where you can start. And we have here like a welcome and a little bit of information about the academy and how to create a free account to become a member of the academy. All right. So when you come in, you can sign in if you already have an account. So I'm going to sign in here into my account. All right. And the first thing that you do when you get here, okay, let me make sure that we have people entering in. Okay. The first thing that you see is the feed page. Okay. This feed page basically has links to the most kind of recent activity in the website, but it's not the most important part. All right. So discovery is also another page that has kind of the most popular things happening. What are all the members, the top members, feature articles, upcoming events, and whatnot. Another important feature that we have here in the website is the members tab. And if you put your location in your profile, so for example, if you come here, you click on your profile picture and go to personal settings, something that is very important is to put what is your location, okay? Because that is going to actually help you find other members near you. Okay, so other members that have kind of the same location or close by location. And that way you can find other families that are also in the academy. The events page shows you what are all the upcoming events or past events that we have had. Okay. And then we finally get here to the home page. I would probably say that this is the place where I usually start, here in the home page, to see what is happening. So the latest postings there in the home page. I have also created another page here for open posts and questions. So I have a lot of, questions here from families about how to do this, how to do that, and so on. You can ask your questions here, and I monitor and try to answer all the questions there. You can also go ahead and answer someone else's question if you know the answer. If you need to communicate with me specifically, use the chat feature. So the chat feature is here in this icon, and you can actually search for someone and specifically start a chat with another member in the academy, in the website. Okay, so this is very useful in order to basically talk one-on-one, or you can actually create groups and talk with several people at a time here in the chatting. So that is also an important feature. Next to the chat, we have here the notifications that, depending on your settings, you can get notifications about different things that are happening, new pages that are being created, or lessons and so on that you may want to check out. Okay. A very important page is here, this one, info and links. All right, so here the information and links page has all the webinars, okay, past webinars and meetings that we've had. We post them here. And also, more important than anything is this page, where you have the weekly schedule, the yearly calendar, tuition information, and how to register for the courses. Okay, make sure that you watch this video and you understand how to register for the courses. One of the main kind of problems and mistakes that sometimes people do is that they register their children with their own account. Okay, and that doesn't work. Whoever registers, whoever pays for the course is the student. All right, and the reason for that is because these courses are really open to anyone. Okay, so we have younger students, we have parents taking the courses as students, and so forth and so on. And so it is important that whoever registers is the student. Okay, if you make a mistake or something, make a chat with me. All right, and then we can figure things out. But that is kind of how things go. All right, so far so good. Any questions at this point? Are we okay? All right, so let me continue here sharing the screen and looking at things. So all the courses for this next school year are under this page, courses 23-24. So we have all the courses listed. And we have 16 courses, guys. This is incredible, really, the amount of courses that we have, the variety and the quality of the courses that we have. If you haven't decided yet which course to take, you can always do a preview of the course, okay? And you can see the overview of the course. And also, you can look at the first week, all the lessons of the first week for the course. All right. So that is also a great thing that we have. So let's take a look at the physics course. Let me see if there's anything else. Oh, and a few other things here. The self-paced courses are going to be under here. All right. So we are going to be publishing more of self-paced courses in this page. These are courses that you can take, but do not have a live class component. You do them basically at your own pace. These are here, we have the courses for last year, so usually you wouldn't need to get access to those. We also have here local groups. So we are hoping to be able to start gathering families, homeschooling families, and well-educated heart families into groups where you can do in-person activities together. So that is also another reason why it is critical that you put your location so you can be found and discovered. So here in North Utah County group, we have some activities Wednesdays at 10:30. We have done also some gatherings at parks and so on. These have been really, really fun. Okay, so really lots of different ways of interacting. And finally, we have here under the Students Corner, we have the student events and activities. Also a teen book club that we just started. And also the students can post things and chat and so on together. We are also creating another area called educational reimbursements. And what we have here, we don't have yet a whole lot of information in all the states, but in some of them we do. And we are basically trying to find what are all the different ways that you could either get scholarships or educational reimbursement for the state where you live. All right. And so look at your state, okay, and you can join that page for your state in order to make sure that you get that. So Owen asked, will the half-year courses be repeated the second semester? That is the idea, yes. So we have two courses that are one semester long, the English course and entrepreneurship. And those courses, we are hoping that they will also be offered in the winter semester, okay? So if you go again here to the info and links page, to the yearly calendar, you can see that you have the first semester, okay, is going to start August 28. That is the first day of classes. We are going to have a mandatory student meeting on August 18, just in a couple of weeks. Holy cow, this summer has gone by fast. All right. And then we start classes, and then the first semester finishes January 19, and the second semester starts January 22nd, and it goes to the end of the school year. Okay, so I hope that that has helped. Does that answer your question, Owen? Okay, so that is there how you find that information. Let's take a look at the physics course and do a preview of this course. Okay, so several of you may have already signed up for this course. Here we have an overview, a little introductory video, and this is basically the main topics that we are going to cover during this year. This course is very conceptual, so we are not going to focus on a lot of math for the course. We are going to do some of that, but mainly in order to help us understand the relationships between different concepts. The textbook that we are going to use is called Conceptual Physics, 8th edition. This is a very popular textbook written by Paul Hewitt. There are several editions. If you cannot find this edition, the 8th edition, buy the next one, the 8th or the 9th edition. They are all very similar. It's not that they are, completely different or anything like that. The only problem is that in different editions, maybe the page numbers may be a little different, some of the wording may be a little different, and so on, but you can still access it. Okay. This book is available on archive.org, and you can check it out, all right, for 1 hour at a time, okay? But, it's not recommended, of course, that you read a textbook online like this 1 hour at a time. I really would recommend that you get a physical copy of the textbook, okay? So we are going to also, I need to add here to the week one things, we are going to also be reading this book, okay, called Revelation Through Science, written by James G. Martin. James Martin is a congressman, okay, and I don't remember from which state. Let me see if I can find out really quickly. Okay. So he was a governor, okay. It says James G. Martin, governor, scientist, and believer, all right? And he has been a governor and also congressman, and I think that he has a very, very good career, all right? And he's also a scientist. And so we are going to be reading different parts of this book. It's not going to be the whole book. We are going to read just some parts of it, but I hope that you are going to find it very, very interesting and kind of giving additional information. All right. Okay, let's see what else we have. Let me share the screen again with you. Okay, let me see. I think that someone else needs to come in. Okay, all right. And so every week we are going to have a reading assignment. So I'm going to give you kind of the instructions of what you need to read. And it is very important that you read the assignment. You do, you watch the videos and do all your assignments 1 week in advance. Okay, so we use kind of what is called the flipped classroom model. All right. So let me see if I can clarify this by going back to the yearly calendar. Okay. So if we look at the yearly calendar, you will see the following. Let's say the physics class, I think that is on Wednesdays. Okay, let's check the weekly calendar to see when the physics class is. So yes, Tuesday. Tuesday is physics. All right, so then when we go here to the yearly calendar, we will see that the first day of class is August 29. All right, that is the end of week 1. So during this week, during the week of August 21st to the 25th, you should be studying all the material and completing your assignments for week 1. Okay, so when we come here to the 29th to the live class, we come to actually discuss and ask questions and go more in depth on the things that you have already studied for week 1. Okay, then after the live class, we start week 2. And so here from 29, 30, 31, and so on, the first. And then September 5th is the second class. So that is the end of week 2. So that is kind of how we are going to be working. All right. 1 week in advance, always going 1 week in advance. All right. Any questions about that? Everything is okay? How do you get to that course overview with the first week's lesson? I can't seem to find it. Okay, so let me go back to that and show you how to get to the preview of the courses. You click here on the courses 23-24, and you can see all the courses listed, and you see that every course has a preview. Okay. So when we go here to the physics course, we see the preview, and we see that we have the overview is available as a preview, and then week 1 is also available as a preview. All right, does that answer the question? Okay, are we okay with that? All right, so we have the textbooks, the reading assignment. Then we are going to also include in each lesson, sometimes, most of the times, we are going to have videos. Okay, and so here we have a video on the importance of measurement, science, art, and religion, the map of science. This is a very interesting video on the map of physics, explaining all the different parts of physics. We are going to also use a software called Labster that allows us to do simulations, okay? And so this page, I don't know why the page is blocked, but all right, let me log in into Labster. This is the Labster software that is going to have different simulations for the classes, okay? So in physics, we are going to do simulations on the scientific method, okay, on different things and so on. These are really fun ways of learning physics, okay, doing some of these simulations. All right. And so then after that, usually the last part here in the week's lesson is the assignment. So here we have physics, week 1, notes and questions. As you study your reading, as you do the reading assignment and watch the videos, I'm going to ask you as a student to write notes of what you learn, okay? And these notes are very important in order to keep track of your own learning. So it's basically a way of you to be able to remember the things that you have learned. Okay, let me see in the chat. There is a question, Amy. You say Labster has a ton of options. Can you provide a link to the right one? Yes, I'm going to actually provide a link to the class itself. All right. So I am renewing the license for Labster. And this year, hopefully we are going to have enough students in the biology and physics class that will be able to cover the license for Labster without having to pay an additional fee. Okay, and so you need to hold on for a little bit until we figure that out and we set up the class for this next year for all the students, and then I'm going to give you the link on how to log into Labster and be added directly to the class. Okay, so for now you don't need to do anything. Don't purchase a license, don't do anything. Okay, for Labster is forthcoming. Does that make sense? Okay, are we okay with that, Amy? Yeah. All right. I think that Claire was another student that was asking about
Yes, sorry.
that. Okay, no problem. No problem. All right. So let me see. Okay. I think that covers basically the overview of the course and what we are going to be doing. Now, I would like to talk with you a little bit about physics. Okay. So, this is something that I have learned that I find actually very, very interesting and very important to do. Okay. So, physics, it's really the study of how the world works. Okay. So it is basically being able to understand how things work in our physical world and in the universe. And scientists have basically discovered that there are 4 fundamental forces in the universe. Okay. Do any of you know what are the 4 fundamental forces? Okay. I actually think that there's 5 fundamental forces. I'm going to add one more here to the mix. Okay. But any one of you can mention or know of what are the fundamental forces of physics? Okay. If you don't know, that is fine. We are here to learn, so no problem at all. Okay. So let's see, you put energy and mass. Okay, so that is these are extremely important concepts. Mass and energy are very important concepts that we are going to talk about a lot here in the course. But these are not actually forces. Okay, so mass is basically the proclivity of something to actually resist a force. Okay, so the mass of an object is how much matter or material there is in that object and how much that object resists movement when a force is actually applied. Okay, and so for example, you know, when I have this book here, I'm holding the book. Okay, the mass is an expression of how much matter the book has. If I have the book on the table, let's say that I have the book here on the table. If I push the book, okay, I have to force, you know, apply a force in order to push the book. The more mass that something has, the harder it is to push it. The lighter it is, the easier it is to push it. Okay, so that is mass. It's kind of the amount of things that are in something. And energy is an extremely important concept in physics. It's basically the capacity to do work. Okay, the capacity to do work. All right. So let's see. The Jones is Owen. Is that your name? Or no? Okay. All right. So
No,
if you can,
this is Marin. I'm Owen's mom.
okay.
He's at
I thought I
he's at
recognized
FSY.
you, Marin. Yeah.
I'm hiding. I'm
Okay.
incognito.
Yeah. If you want to put your name, you can rename yourself by clicking on the three dots, okay, in the corner of your video, and then there's a rename option. Okay. So that way when I call you, that will be a little easier for me, you know. So okay. All right. So Maren, you put gravity. Gravity is actually one of the four fundamental forces of physics. All right. Perpetual motion is not a force, it's a myth. Okay, so perpetual motion is basically something that scientists have been trying to get at, but you cannot really get perpetual motion. Okay, so always, in order to continue motion, to have perpetual motion, you have to keep spending some energy, putting some more energy into the motion in order to make it perpetual. But gravity is one of the four fundamental forces. And then here, Isabel Graham, you take the prize by naming all four of the fundamental forces: the weak nuclear force, the strong nuclear force, electromagnetism, and gravity. Okay. Thomas, you put, how about kinematics? So kinematics is a topic of physics. It's not a force. Kinematics means the study of movement. Okay. Kinema means movement in Greek. Okay, so kinematics is the study of movement. So how things move is the study of kinematics. So, but Isabel is correct. Okay, so round of applause for Isabel. Great there. Good job. Yeah, a round of applause. There we go. All right. So in naming all four of the fundamental forces of physics, gravity is the most obvious of these forces. We feel it all the time. And the force of gravity is basically the attraction that objects have with mass. All right. So whenever you have an object that has mass, like what we were talking, this object is going to attract other objects proportionally to the mass of the object and inversely proportionally to the distance between the two objects. Okay, so I have here a paper clip and the book. Okay, the paper clip is really not very massive. Okay, it's very, very light. It doesn't have a lot of mass, but it has some mass. The book is more massive. Even though we don't feel it, I don't feel anything pushing the paper clip towards the book, there is a little bit of gravitational force between the paper clip and the book because of the mass of the book. Okay. Now, what happens if I let this paper clip go? All right. Okay. Oh, okay. Now I lost my paper. I need a paper clip. So what happened to the paper clip? Okay. What happened to the paper clip there? You may have heard there a cling there, all right, as I let go of the paper clip. So what happened and why it happened? What do you see? Thomas, what do you think? What happened to the paper clip? Unmute yourself and give me your best shot there. You can do it. So I let go of the paper clip, punk, so we can see why. Why does it fall? Why does the paper clip fall? What is happening there? Okay. Anyone else? Okay. Thomas, go ahead.
Am I supposed to tell you or put it in the chat or?
No, tell me. Yes, let's talk.
Okay, it fell. Gravity.
Gravity of what?
The Earth.
The Earth. Yes, excellent. Okay. Oh, so you put it in the chat. I didn't see it in the chat. Okay. So that is good. All right. So gravity. So the Earth is very big and very massive. It's really, really massive. And that generates a bend in the gravitational field. Okay, so the Earth causes a gravitational field and attracts other objects that are close by to it. Okay, and that is why we stay standing up on the Earth. We don't float around, and that is why things fall towards the Earth. It's the force of gravity. There are several really interesting things about the force of gravity that happen together. Okay. Amy is asking, is gravity the reason the last few Cheerios in the bowl cling together? No, it's not gravity. So is the second fundamental force is electromagnetism. Okay, believe it or not, okay, most other things that we see around are affected by the electromagnetic force, all right? And so, for example, the adhesion of molecules to water, and that is what makes the last few Cheerios cling together in the bowl, it's mediated by the electromagnetic force. It's not magnetism. The Cheerios are not magnetic, but the molecules between the water, the sugar molecules in the milk, and the sugar molecules in the Cheerios make an electromagnetic force that adheres the molecules together. And that is actually why the Cheerios move together. So electromagnetism is a really, really important force in physics and in chemistry. All chemical reactions, pretty much, okay, yeah, really, all chemical reactions are mediated by the electromagnetic force. the electrons, the force of the electrons is responsible for the forces and the chemical reactions. So the electromagnetic force is a very, very important. An interesting thing to consider is that the electromagnetic force is a lot stronger than the gravitational force. The gravitational force is the weakest of all the forces, even though it's the one that we feel all the time, okay, it is the weakest of all. Let me demonstrate how weak the gravitational force is compared to the electromagnetic force. I have here, I need to probably move a little bit because I have too much sun now here on this area. So let me see if I can move a little bit away from the sun. Okay. All right. This is not going to last very long, but let's give it a try. Okay, so let's see. All right. So here I'm going to show you the famous paperclip. Okay, so the famous paperclip is going to be attracted to the table by the gravitational force. Okay, so you see there the paperclip. Okay, the huge Earth has a lot of gravitational impact. Okay, so it generates quite a strong gravitational field. But here I have my watch charger. The watch charger has a little magnet into it. Okay, you know, when you put the watch to charge, you can put it kind of on there. See this, when I just approach the magnet, okay, to the paperclip, the magnet, this little magnet, okay, and it's not very strong magnet, is able to counteract all the gravitational force of the Earth. Okay, so does that make sense? This is how weak the gravitational force is compared to the electromagnetic force. This little magnet is able to overcome all the gravitational force of the Earth. Okay. Wow. That is something, not, talk about, even we have much larger magnets that generate a lot of stronger electromagnetic fields. But just a little magnet is able to counteract the effect of the whole Earth's gravitational field. That's how weak the gravitational force is compared to the electromagnetic force. Okay. And like we mentioned before, yes, the electromagnetic force is the force that is responsible for all chemical reactions and most of the interactions that we see in the physical world. Okay, so the electromagnetic force is everywhere, really. Okay. Then we have the strong nuclear force. The strong nuclear force is the force that holds protons and neutrons together in the atom of anything. Okay, in any atom, when you have protons held together, they are held together by the strong nuclear force. Okay, and let's talk a little bit about the electromagnetic force. Do you remember probably hearing that in electric charges that are of the same polarity repel, okay? And charges that are of different polarity attract each other, okay? Yeah? And you probably have seen more of this. Instead of with charges, you see with magnets. If you put two magnets with the same polarity, they repel each other, okay? It's very hard to push them together. If they have different polarity, they attract together and they actually snap together, okay? Well, the same thing happens at the atomic level with atomic charges. You may know that electrons have a negative charge and protons have a positive charge. And so because of these different charges, the electron is attracted to the protons and they stay together in the atom, okay? And so that is how we have matter. That is what makes matter. Protons and electrons being held together by the electromagnetic force of attraction. They attract each other. Now, the problem is, how do you get two protons that have the same charge, they are positively charged, how do you get them to stick together? Because think about it, they have the same charge. The closer that you push them together, the stronger is going to be the repulsion of the protons. Okay? Does that make sense? It's like when you try to put two magnets together of the same polarity, the closer that you try to push them together, the stronger that they are going to try to pull apart. Okay? Well, so protons don't want to stay together because they have the same polarity. They really repel each other. That is where the strong nuclear force comes into play. Okay? The strong nuclear force, the best way that I have to describe it, is the force that holds protons together even though they want to repel each other. Okay, the strong nuclear force is very, very strong, but it only works at very small distances. If you have two protons that are separated, the harder that you push them together, the stronger that they are going to try to pull apart. However, if you are able to actually get the protons to kind of touch each other, then the strong nuclear force takes over and is able to glue them together, to keep them together. It's kind of like Velcro, okay? Think about, the strong nuclear force as Velcro for protons, all right? So, when you have two pieces of Velcro, if they are close by, nothing happens. Okay, when does the word Velcro work? When they actually touch each other, yeah. And then when it touches each other, Velcro becomes very strong, all right? Well, that is exactly how the strong nuclear force works. So you have to actually push the protons all the way to touching, and then the strong nuclear force is able to keep them together, all right? Neutrons and protons in nuclei of atoms is what actually helps them stick together to one another, all right? The only place, okay, where you have enough forces of gravity in order to push the protons close enough to now the strong nuclear force to bind them together is in the core of the stars. So that is what happens in the core of stars. The strong nuclear force starts making heavier elements. You need to have those forces, the forces of the stars, in order for this to happen. When you put two protons of hydrogen together, just single protons, and you fuse them together, you get helium. And you get a ton of energy. That is the energy of the sun. Okay, the light of the sun is the energy that is released when you overcome the electromagnetic repulsion and you actually glue the protons together. Okay, so that is what happens, and that is what happens all the time in the sun. All right. Does that make sense? Are we following okay? Okay. Yeah. All right. Great. Excellent. Okay. So now the weak nuclear force is also a force that deals with the nucleus of atoms, but the weak nuclear force is now in charge of decaying the nucleus of atoms, okay? And it is in charge of the radioactive materials. So let me share with you this picture that I found there in the Wikipedia article on the weak nuclear force that is very, helpful in order for us to understand how it happens. So you have here the nucleus of a heavy element, okay? And when the nucleus becomes very large, sometimes the weak nuclear force changes a neutron into a proton, okay? And when that happens, the neutron actually emits an electron and an anti-electron neutrino is called. Okay, so this one we don't care too much about. This one is now an electron that is free, and so you see it kind of coming out of the nucleus of the atom. And the interesting thing is that now this neutron becomes a proton because the neutron is neutral, but as it discharges a negative electric charge, then it becomes positively charged and becomes a proton. Okay. The weak nuclear force is in charge of governing when these things happen. And these things happen on radioactive materials. Any isotope that is unstable, the weak nuclear force is going to basically transform it into another element. Okay? So that is really what the nuclear reactions happen. There are some elements that are naturally radioactive, and the weak nuclear force divides those atoms or transforms those atoms into other things, and you have the emissions that are common in radioactive materials, okay? Most likely, most materials are not radioactive, all right, until they stay pretty much forever, okay? But those are the four fundamental forces of nature. We have the gravitational force, the electromagnetic force, the strong nuclear force, and the weak nuclear force. Okay? So those are the four. All right. Do you have any questions about this? Was this useful, helpful, enlightening? Okay. Clear? All right. This is hopefully kind of giving you a taste of how we are going to do the physics class. Okay. So we are able to kind of understand things clearly. I get a thumbs up there from Maren. Thank you so much. Okay. So let's see. So you, Thomas, you also put there in the chat. Okay, that is also why water climbs up a straw and how it clings together and so on. So that is very, very important. That is the electromagnetic force. The electromagnetic force mediates a lot of the physical and chemical interactions that we see on our day-to-day life. Okay. So now, I actually think that there is a fifth fundamental force in nature. And this force is what we can call, okay, the force of the priesthood or the power of the priesthood, okay, or the power of God. Sometimes the scriptures call it the light of Christ, okay? And that is actually probably the most important of all fundamental forces, because it really works everywhere. Okay. So think about it. Think about this. What happens when you pray? What conducts that prayer to God and the answer that you receive from that prayer back to you? Okay. It is really, really interesting to think about it. So that power is actually a manifestation of this fundamental force of the power of God or the light of Christ, the power of the priesthood. Okay. I have, had many, many experiences, miraculous experiences that I cannot deny, where I have seen the manifestation of this power, this force in my life and in others' lives. Through blessings being received or given, the promptings that I receive, all these things are all manifestations really of this very important fundamental force. The fact that that is difficult for us to quantify or to predict or to manipulate doesn't make it any less real, okay? Because, when you think about it, for most of the history of the world, we didn't know anything about the gravitational force, the electromagnetic force, the weak nuclear force, or the strong nuclear force. They were there all the time. Okay, we didn't know about them. All right. Well, so actually, this fifth fundamental force was actually more well known and has been part of the history of mankind throughout history. Okay. And it is actually a very, very important and critical force for us to recognize. All right. Okay. I thank you so much for listening and for participating. I want to now ask if there are any questions, okay, from you about this or anything else, anything about the classes or registration or physics or anything that you want to ask. Mm-hmm. Thank you for letting me share this lesson on the fundamental forces of the universe. Mm-hmm. Okay. Let's see. We have here Claire. You say, I saw something about submitting pictures of notes each week. Okay. When are those notes due? Great question, Claire. So the notes are due every single week. All right. Before the live class. So let me share a couple of examples of these notes, how these notes look like. And I'm going to pull here. Let me see. I'm going to actually switch my account. I have two accounts. One is my host account, and then another one is where I can simulate being a student, if you wish. All right. So, but let me sign into this and show you some examples of what we expect in these notes. So I'm going to look at this, the previous year's course, okay? And we'll take a look at this. Let's go to week 4 here. Okay, so here in week 4, for example, we have the lesson is about nonlinear motion, and we have the reading assignment, like always, reading assignment, videos, simulation, and other things. And then here on the notes and questions, I kind of give you an outline of what I want in your notes, all right? And the instructions say that you have to write your notes by hand in a notebook, a bound notebook, not 3-ring binders or loose pages, please. Okay. And then you write your notes as you read, and then you add your notes at the bottom of this lesson as a document, okay? So you put them here together, so then I can actually read them this way. So here is one example. Okay, this one is not an extremely good example, I guess. Let me see if I can take a look at these ones. All right, this one is a Word document. And then these ones are PDF files. So here is one example of a student with a Word document. You don't need to, please make sure that the pictures are oriented correctly so I can read them without, developing a neck ache. Okay. So this is good. This is a good picture, and you can add the pictures and put them all into one page. Okay. So let me see if I have a couple of other examples. Okay. So this is another student with the notes. All right, so very good notes. And then I can read the notes here, and you can also ask questions or answer the questions from the textbook. So this is one of the questions in the textbook. You write the question and then you write your answer. All right. The reason why we do this by hand is because it's a lot easier to draw things, to make formulas and so on by writing them than trying to do this online. All right. So this is an example of the type of notes that I'm expecting. Very good notes. These notes are very, very good from this student. Okay, let me see these other notes. Okay, another example here. All right, so here we have also nonlinear motion, and see the notes you can draw. Can you see how useful these are in order to help you understand and remember the things that you are learning? You draw things. These are drawings from the videos, questions from the textbooks, problems that you can solve, and so on. And you submit this at the end of each week before the live class, and I can read this quickly and give you feedback. So I give feedback to all the students as they turn in their notes, okay? So you will be able to see some of the other students' notes, and then you click here on share your thoughts, okay? You click on this icon and upload a file, okay? So you can upload the file with your notes. So that is kind of how it goes, all right? So Claire, does that help answer that question of how you turn in your notes? Okay, yeah. All right, so every week we want to see that there. Okay, so let me see. Okay, all right, so thank you. Amy, would you like to talk about the Student Leadership Council? Yeah, you are muted. And let's unmute yourself.
Sorry, thank you.
Yeah.
Yes, so this year for student activities, we're really excited. We're going to start a Student Community Leadership Council, and they are going to be primarily responsible for helping plan the student life, student activities that we do online and possibly also in person. And hopefully we're going to have 1 to 2 students from each of the 16 classes be members of that council, and we'll meet, we'll have a regularly scheduled Zoom meeting every other week, I think. And we are also possibly putting together a retreat for that council so that they can be a little bit unified and get to know each other. The main goal of the Student Community Leadership Council will be to help the students to feel unified, which is a significant challenge when we're spread out across the planet. So just spread the word, and if you're interested in participating in that council, shoot me a message, and we'll be making an announcement in each of the classes as well.
Excellent. Thank you, Amy. Amy is a volunteer parent, okay, helping put a lot of different activities, this leadership, student council, and so on. So we are very, very blessed to have parents and students, but parents willing to help and do different things here in this academy. This is a labor of love, really, more than anything. Okay. So thank you, Amy, for that. I really, really appreciate it. Thomas, you put in the chat, I don't know if this is a question or a comment, but it says, I need to study everyone else's notes. That stuff looks amazing. Yes, that is one of the advantages, that you really can look at everyone else's notes. You don't have to study them. Okay, I want to see your notes, all right? But we
Planning on
actually
using their notes, but I wasn't
Hey.
planning on using their notes, but it would be nice to know some stuff. And before that, I asked, where do we submit our stuff?
Yes, okay, so right then and there. So that is precisely the thing. Okay, so let me go again. Good question, Thomas. So we actually so in here in the lesson, okay, so every week you have this lesson that says, you know, week 6, for example, week 6 physics notes and questions. Okay. If you scroll down to the bottom of the lesson, you are going to see the submissions of the other students, and then you keep going to the bottom of it, and then you get to share your thoughts, and that is where you submit your lesson, your assignment. Okay. Does that make sense? You click there on the plus, okay, and you click on add photo or file. And I want you not to add just a photo like this one, but add a file, okay? A PDF file is best. It can be also a Word document, okay? And so on, but that is kind of how we do it, okay? So these are the best ones, you know, the PDFs, because you can easily see them and see all the notes that the students take, okay? Some students take many pages, others are able to do it in one page, and that is perfectly okay, perfectly fine. Mm-hmm. Yeah?
Yeah.
Yes, So the main thing that I want, Thomas, is for you to show me what you are learning.
Okay.
Okay. Yeah. If you have a question for me, if there's something that you don't understand or you want to discuss more in the class, you can write those questions there in your assignment, in your notebook, okay?
Okay.
And so then I'll see those questions and we'll be able to answer them. All right, during the class. Uh-huh.
Yeah.
Yeah.
I already signed up, so.
Excellent, excellent. Oh my goodness, we are going to have a great year here.
Yeah, I can tell already.
Yeah.
Maybe fun.
That is great. All right, excellent. Well, thank you so much for joining in the webinar, for helping out and participating in the chat and asking questions and everything. So let me stop the recording here. There we go.